So today we're going over chapter 10, section 3, using chords. We're going over theorem 10.6, congruent corresponding chord theorems. It states, in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. The key words right here are if and only if.
Miss, are we going back to this? No.
Alright, so for example, arc AB is congruent to CD if and only if AB is congruent to CD, the segments. So you can say these two arcs are congruent because their segments are congruent. We have theorem 10.7, perpendicular chord bisector theorem. States if a diameter of a circle is perpendicular to a chord, then the diameter bisects each chord and it's arced. So if EG is the diameter and EG is perpendicular to DF, then HD and HF and their arcs are congruent. So guys, if you guys can relate this to other things that we've done, when we have a perpendicular line, and since the circle is congruent all around, if we break that perpendicular line into two segments, those two segments are going to be congruent. As long as, of course, they're perpendicular to the diameter, which is the important part right here. The diameter is what gives you if it's going to be congruent or not, as well as a 90 degree. 10.8 is perpendicular chord bisector converse. So if one chord is perpendicular bisector of another chord, then the first chord is a diameter. So this is the converse, so we go backwards. So if QS is perpendicular bisector of TR, so telling us this line right here, perpendicular bisects TR, which is this line right here, then QS is the diameter of the circle. So if you have a line or a chord, which is what we're using right now, if you have a chord and you have a segment that is perpendicular bisects it, that is the diameter. So before we went from, we have the diameter, here's the chord, now we have the chord, so it's half the diameter. So we have theorem 10.9, equidistant chord theorems. So in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So another way you can figure out if the chords are congruent is if you have your center of the circle and you have a line right here and a line right here, that they're both perpendicular and they are the same distance from the center. So if AB is congruent to segment CD, if and only if EF and EG are equal. So these two have to be equal in order for those chords to be congruent. So again, if and only if. So there's only one thing that needs to be met, and then after that, they will be congruent. So for this example, they want us to find the value of X and Y. So in order to find the values of X and Y, we need to know a few things. We know this line right here is the diameter. So we know that this is the radius. Now the radius is it's gonna be the 13. I don't know why we updated the PowerPoint. It's gonna look in a different place, but the 13 is the radius. So we can use the Pythagorean theorem to solve this. Since X and Y are going to be the same as long as you find one is more than enough. So I can do X squared plus 5 squared equals 13 squared. So that's going to be X squared plus 25 equals 169. I will subtract 25 on both sides. We get X squared equals to 12. Sorry, not to 12. I finished to 144. We take the square root, and then we get X is equal to 12. Now, because we know 12 and Y are going to be the same, we know Y is going to be 12. How do we know they're going to be the same? They're going to be the same because of theorem 10.7. That is the perpendicular chord bisector theorem that states if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its area. So because this is a 90 degree diameter with the chord, we know the X and the Y will be the same. So in order to solve B, we're going to have to realize that this is a 30, 60, 90 triangle. So we're going to have to use the special right triangle. So I'm going to draw it up here just to have it. 30, 60, 90. So this is A, a root 3, 2a. Now knowing that, we know y is going to be our a. We know x is going to be our 3 root 3. And we can go from there. And we have the 6a, the 2a, which is our 6. So we can say 6 equals 2a. So our a is equal to 3. So we know y is 3. X is 3 root 3. Or so I'm just going to write 3 root 3. So we should be able to find arc AB. Arc AB is going to be the addition of those central angles. Now our central angle for, let's call this D, for our arc AD is 60. And since we figure out that they are congruent, we have to find X, Y, and C, and arc AB, sorry. We know that's going to be another triangle this way, so we know the arc for DB is also going to be 60. So we can say that the arc AB, the measure of arc AB, is going to be 60 plus 60. So that's going to give us that it's going to be 120. But you find X and B by using the special right triangles. And since they are congruent, we can say that the arc is going to be 60 plus 60. So we're able to solve it. Now for C, they want us X and Y. Now this is based on theorem 10.9, the equidistant chord theorem, which states that if they're the same distance apart, the two chords from the center, then they're going to be congruent. Now, they told us right here that they are congruent, so we can go ahead and assume that those are congruent. So because 8 represents this section right here, and X is exactly the same, X is going to be 8. Now, Y is going to be the whole segment, the 8 plus the other 8, so we know Y is going to be 16. Also, I don't want to forget to mention that it has to be a bisector from that line to the chord, like we have right here. It's the only way to make sure they are also at the same angle, so they're going to be the same no matter what. For example, 2, they want us to find the measure of arc CD in the diagram. So in order to solve for it, we're going to have to find what each angle measure is, so we're able to solve it. Since it's not a central angle, we can just add the 90 degrees. So we have to find what the actual degree is based on these formulas. Now, because of the theorem 10.7, we can use the bisector chord, the perpendicular chord bisector theorem. I was trying to remember the name in order to do this. Because this chord is being bisected by a diameter and it's perpendicular, I can say those two are congruent. So I can say 9x is equal to 80 minus x. So I can go ahead and add the x on both sides to get 10x is equal to 80. So I then divide by 10 on both sides, and I get that x is equal to 8. Now, that would not be your final answer. Here's where you have to make sure you read the question, because they're asking for the arc of CD, not just x. So in doing that, we're going to plug it in. So CD is going to be equal to 9 times x, so it's going to be 9 times 8. So arc CD, which is what they're asking for, which is this segment right here, it's going to be 72 degrees. Now, if they were to have asked for BC or BE, for example, they asked for BC, just kind of as an example, and you don't have any information, you can do 180 minus 72 to get 108 degrees. Because even though this is not a central angle, this is still a semicircle. This part right here is still a semicircle. Even if it's not in the center, which will make it a lot easier, but technically you can still do that if they were to ask you for BC or BE. But for BE, you would have to find ED first and then subtract it from 180. So here is example 3. In the diagram, they're telling us circle C, QR is equal to SC. So I'm going to, well, it's already marked with 16 and 16, and they both equal 16. They want us to find CU. Now, because we know those chords are the congruent, we can also say that those segments right here, UC and CV, are congruent because of theorem the equidistant chords theorem. I can't remember the number right now. So we can just go ahead and do 2x is equal to 5x minus 9. I'm going to subtract the 5x on both sides. So I get negative 3x is equal to negative 9. So that's after dividing by negative 3, I get x is equal to 3. Now again, they're not asking you for x, they're asking you for the segment. So the segment CU is 2x, so we're going to say CU is 2 times 3 or 3 times 2. So segment CU is 6. So this is your final answer. Now, this is it for today's notes, guys. You do have homework, get some big ideas. There's only 10 questions, but we're done for today with these notes.